times 10 to the 20 antineutrinos per second coming out of the reactor. That's 5.6 with 19 zeros after it. Fine. And this was then made use of in 1950 in a project called Project Poltergeist, in which Reines and Cohen, two physicists, placed a detector near a reactor in Savannah River in South Carolina, and the antineutrinos coming out of the reactor interacted with protons in their detector, giving a positive electron called a positron and a neutron, both of which then emitted some light, which was turned by their detector into electrical pulses that were recorded. They announced their discovery. And a mere 39 years later, Reines was awarded the Nobel Prize. So if you want to have a Nobel Prize, you better do your research very early in life. Unfortunately, Cohen had passed away by that time. Well, let's talk about the siblings now. A particle called the pion, denoted by the Greek letter pi, was found to decay, to break up, into another particle called the muon, denoted by the Greek letter mu. This muon has all the same properties as an electron, except that it's much heavier. So again, they found that the energy of the muon was always less than the energy of the pion. But by that time, physicists got wise, and they of course all said, well, it's just a neutrino. The question is, was it the same neutrino as Reines's? Reines's was produced together with an electron, and when it interacted, it gave you an electron. This one was produced together with a muon, and so what was it going to give? Was it going to give an electron, in which case it would be the same as Reines's, or something else? And so this was then investigated by three physicists from Nevis, Lederman, Schwartz, and Steinberger, who designed a beam of neutrinos coming from the decay of pions, and for that they used what was then the highest energy accelerator in the world, the one at Brookhaven on Long Island. This is a ring of 600 meters circumference with magnets all around it, and it's a machine that has been very productive and actually still exists. Okay, so how do you produce a beam of neutrinos? And here's another movie. So the accelerator propels protons, which then hits a graphite target. In that, one of the particle protons interacts, producing pions, positive and negative, and it's the positive we want. So we put a system of magnets called a magnetic horn that selects the ones you want, the positive ones, and rejects everything else. And then these guys that survive decay into a neutrino and a muon. All you have to do then is get rid of the muons and every other particle and just keep the neutrinos going, because they're the ones that don't interact, and there you go, you've got a beam. And at that point, you put a detector at the end of the beam, and the detector they chose consists of spark chambers, and that was the question they had to answer. So what's a spark chamber? It's a series of steel plates immersed in a gas. Every other plate is held at a very high voltage, so that when a charged particle traverses this detector, it ionizes the gas. That means it releases a few electrons, which then shorts the two successive plates, generating a spark. You take a picture of this succession of sparks, and that gives you the track of the particle. An electron, on the other hand, is much lighter, and when it comes in, it scatters off, changes direction, emitting a photon, which is a chunk of light, which breaks up into an electron and a positron, which then emits more photons, which again break up. So you have this succession of positrons and electrons going through the detector, and the sparks that you get look like a shower, and that's what they're referred to. showers. Okay? So the idea is to look for events that either give you a straight line or a shower. And the answer was they got a straight line. So the neutrino did not give you electrons like rhinuses. Instead, it gave you muons, and that made it a totally different particle. And for that, the three of them, by the way, here's the publication, the Nevis Laboratory in 1962. I came here in 63. If I'd been just a couple of years earlier, I could have maybe participated, but nonetheless, okay. So here they are. They got the Nobel Prize in 1988. This time only 26 years. Fine. So eventually yet a third heavy electron was found, the tau, and in due course its corresponding neutrino was found. And so now we